All right, everyone. Welcome to class number one. My name is Sam McQuiston. I will be your host for tonight and for the next few weeks as we learn SQL. I have some materials prepped for us, and I have plenty of things to teach you about. So I will go ahead and start sharing my screen, and we will get going. So, like I said, my name is Sam McQuiston. I am a business intelligence engineer slash architect at CoreStream. This is a company that's currently based out of Florida, and we are an HR voluntary benefits company. So anything but core medical dental vision, that is my area of expertise as of the last year. I have also worked at multiple other places in the Omaha area, which is kind of how I got affiliated with Nate and the Omaha Data Science Academy. I've worked at Medical Solutions. That's a travel nursing staffing company that is based out of Omaha, where I was a business intelligence analyst and visualization engineer for about 3 years. And I was also in systems engineering at Union Pacific for approximately 3 years. If you have any questions on some of the projects that I worked on at each of these employers, if I don't mention them specifically, feel free to ask me about them because I'd love to share more with you. My goal in this class for you guys is to provide you with a learning experience that improves your ability to translate questions into a query, more specifically, a data query. Because more than anything, I want you to have the ability to make data driven decisions for either yourself, your organization, or even the company that you work for eventually when you proceed into the data science realm. My education, I graduated from Creighton University, where I studied business intelligence and analytics, as well as economics as a double major. Some of the things that I like to do outside of my normal day to day are I like to think that I'm a amateur professional chef. I really enjoy cooking. Um, I like to recreate recipes that I see either on YouTube or on the Food Channel. Guy Fieri and Bobby Flay are some of my favorites. I also got into cycling within the last couple of years. So that's, I think, a little bit of a part of me that likes data. I collect all the data on all of my bike rides. So I know how fast I went, the type of elevation gain that I had, the amount of time that I went. And I gradually started to train myself just actually using those numbers and those metrics that were tracked to improve my physical exercising. I also love to play computer games. I built my own PC and I game all the time. My favorite games are RuneScape and Sid Meier's Civilization 5 and 6. I love strategy games and MMOs. And then when I'm not in the office or inside, I do like to get outside. So other than cycling, I do like to do backcountry hiking and skiing, which brings me to my next point. When I do backcountry hiking, that picture in the top right was actually from over the last summer, where got engaged to my longtime now fiance, McKenna. We've been together for about 8 years now. Looking forward to spending plenty more time together, I'm sure. Like I said, I'm a Nebraska native. I was born, raised, and educated in Nebraska. Born in Lincoln, raised in Northeast Nebraska in a small town called Pender. I graduated high school out in the panhandle of Nebraska, Scottsbluff. And like I said, I graduated college from Creighton. So I had been in Nebraska for nearly my entire life until recently we moved to Denver, Colorado, approximately a month ago. So far, so good. Obviously, I still have plenty to learn about the area, but it has been very enjoyable thus far. Me and McKenna, my fiance, have two cats. Their names are Lola and Luna. I don't have any pictures of them, but they are calico short hair cats. They're the cutest things. And my favorite thing to cook and eat is Mexican food. That's just one of the areas of cuisine that I enjoy making, perfecting, learning about some of the different ingredients that are natively in these kinds of dishes. So as you can see, I'm quite an enjoyable person to be around. But that's enough about me. I want to get to know each of you. Tell me how to pronounce your name because, as I think a lot of you are here for this, even my last name can be complicated. So please tell me how to pronounce your first and last name. Tell me about where you're from, and if you're not from where you currently live, where are you originally from? what's your current job or your field of expertise, and tell me more about what interested in you in this class. And finally, but most importantly, I want to know what each of you hopes to get out of this class in the coming weeks. There's going to be a lot that we cover, but if I know exactly what you're looking for, it's going to help me tailor my curriculum for your learning. So we'll go ahead and get started. If we want to go in alphabetical order, we can go in ascending or descending order. Or if we have volunteers, I'll let anyone volunteer to take the helm.
Can you hear me?
Yep.
Oh, perfect. It's one of those you never know with the stuff you put in your ears if it's working or not. So, Ryan Lawrence, I am in Omaha. I am good friends with Nate Watson. That's how I was introduced. I'm originally from a small town in Kansas called Harper. We moved here for my wife's job 16 years ago. She's an attorney. Current job, I am an entrepreneur. I own a business that helps small businesses from a vendor side, both payments and payroll, and some benefits. Actually, I have my life and health license. What interests you in this class? Oh, I actually have a tech startup. And what interests me is I don't have the tech expertise, and I hated when we're developing our stack, not knowing what questions to ask. So this is more just to give a big dum-dum some exposure to kind of help know what questions to ask in the long run. And to get out of the class, like I said, just some experience and exposure. So that way maybe I can see some angles, especially with our tech we're developing because right now we're not worrying about data and analytics, but I want us to as soon as possible. So,
all right. Well, again, welcome, Ryan, and thank you.
Thank you.
Any other volunteers?
I can volunteer.
All right.
I'm Brenda. My last name, I doubt you guys will pronounce it right, except for Ana maybe, but Agüero Carranza is my last names. As you can see, it's not hyphenated for a reason. Those are the first name is my dad's last name. The second one is my mom's name, and it's traditional to have both last names. So if you ever notice that in Hispanic individuals, that's why, because it's kind of like descending back from your heritage, I guess. Like lineage, if anything. And so, but you can just call me Brenda. There's no need for my last names to be pronounced at all. I am originally from Mexico, Coahuila, Ciudad Acuña. It's right on the border of Del Rio, Texas. I was raised here though in Omaha. And then my current job or field is education. But I primarily work with individuals with disabilities, ages 14 to 21. And the reason that I'm interested in this class is because I actually took a SQL class with a different program called Black. Actually, Charity and Rochelle were in that same class with me. And I believe I think I speak for both of them that we still have an interest in it, but I think we just need to get a little bit of a different angle of what SQL is and what we can do with it. And I really hope that I can get that out of this class as well as use it for my own personal, just like aspirations. Like I think it was cool, Sam, that you said, I use it for biking. My husband's a biker, and I'm sure he would love it if I could create something with data. But for me, it would be more so like maybe budgeting, or it would be maybe more so on maybe like the crafts that I do or gardening. I'm really into gardening. So I would like to utilize it also for my personal use, just so then I can see the value that data-driven decisions could be made.
Awesome. Well, I think those are also all really good reasons to do even personal projects in data science. The biking and the budgeting things are actually a couple of examples that I had considered using in this course. So I'll think about cleaning up my data set for the budgeting part. And I'll also consider using the biking example to show you the things that you might want to track and ways that you could use SQL to then track your progress or even track some of your metrics. So awesome to hear, and welcome to the class.
I guess I could go next. My name is Ted Ottenheimer. I am from Pennsylvania, although you are aware, I travel a lot, so don't expect to be at my house for any of the classes through the rest of this course anyway. But originally from South Jersey, spent 9 years there before we moved up to the mountains of Pennsylvania, and I just took to the mountains better than I did the beach life. But I think you can understand that.
Yes, I can.
So I am currently the VP of Clinical Data Transformation for ASCOM. James also works here at ASCOM with me, doing a little bit of a different position, but the concepts that I've been working on and doing over the past many years have been a manual type process, leveraging spreadsheets and not really leveraging what the potential is from all of the separate disparate systems we have, which all have their own databases. They're all not aligned yet, and you're just not getting the fidelity of data I'd like to see. So in working with Nate and some others to start developing the next generation of clinical data analytics, I quickly found out what I need to learn, and this is why I'm here. So, I don't expect to be an expert, but I expect to be able to fully comprehend and do what I need to do to prove my point and build a better product. So that's the intention of why I'm here.
Awesome. Well, thank you for that, and welcome to the course.
Thanks.
All right, I'm going to choose somebody. Charity, I'm going to have you go first. And you're on mute.
I was talking this whole time. Hi, my name is Charity Mwandi, and I am originally from East Africa. Been living in Nebraska since 2006, but we came to U.S. back in 2003. Lived in California the first 3 years of living in the U.S. before we came to Nebraska. My current job is I am a branch operation manager for Wells Fargo. What interested me in this class is, just as Brenda mentioned, we were taking some SQL classes before. Didn't go too much into it, so I would like to explore that a little bit more. And then also just working in the banking world and seeing the changes that's been happening, because I've been working there for almost 9 years. What it was then and how it is now, everything's more technology. So in a couple of years, I already know they're going to get rid of my job. So just kind of preparing for the future. And then what do I hope to get out of this class is, I don't want to say to be an expert, but kind of just to be, I guess, to really know what I'm doing when it comes to SQL. Don't really have a hobby. It was running. So if I do get back into it, maybe, I guess, figure that out, how SQL and running will go together.
Awesome. Well, I think I have the perfect data set for us. It sounds like more and more I need to use the Viking data set, but thank you for sharing, Charity, and welcome.
Thank you.
All right, we have Anna and James and Rochelle left.
I'll go. You pronounced my name correctly. It's Rochelle Walker. I am born and raised in Omaha, Nebraska. I currently work at MUD, the gas and water company, in their customer service department. What interested me in this class is, honestly just wanting to further my career in tech. I was in class with Charity and Brenda, and Nathan came and talked to our class. He definitely left an imprint, and just, being given the opportunity Code Black gave us to network and meet someone like Nate, landed us in the academy. So I'm very thankful for that. So I'm just hoping to learn skills that I can then, pretty much put in my resume, apply to my everyday job to, further my career, so I can support my kids. So, yep, thankful to be here.
Thank you, Rochelle. All right, Anna or James?
I can go next.
I think because we're next to each other. I'm like,
Does it sound better now?
Yep.
I don't know. Can you guys hear me?
Yep.
Okay. I think, yeah. So, I'm Anna. My last name is Mora Becerra. I am originally from Mexico. I was actually born in Guadalajara, Mexico, and I've grown up most of my life here in Omaha, Nebraska. What else? I currently work giving services to the community, getting their taxes done for free, so it's low to moderate income families. And I was interested in this class because I like things that challenge me and keep my brain occupied. So like coding is one of those things that I was actually curious about. So in this class, I kind of just want to learn the basics, and then see how far I can get with that.
All right, thank you. And last but not least, James.
Hey, I'm James. I also work for ASCOM like Ted. Where are you from now? I live in Houston, Texas. I'm originally from Fayetteville, North Carolina, and my job is software install with ASCOM. And what made me interested in this class is we essentially write our software using Microsoft SQL Server. So that's what definitely interests me about this class. What I hope to get out of this class, definitely be more well versed in SQL than what I am now, other than my high level understanding. That's about it.
All right. Well, I can kind of relate. I'm very familiar with SQL Server because that's the product that I kind of hitched my wagon to many years ago when I got into data itself. But it's great to hear that you already kind of have some exposure. And it sounds like most of you already kind of have exposure to data in some form or fashion, whether you know it or not. But thank you, James, for sharing.
No problem.
All right. Let's move on. So you're all probably wondering how this class is going to go. We're going to have approximately 6 classes in the coming weeks. And it is my hope that in this first class, we can kind of do an overview, make sure that all of you are set up, which I think everyone is, and then review some of the materials that you guys covered in the first few classes. We'll also discuss our new dev environment, and I'll go over some of the specifics and how it fits into the overall data architecture that many of you will or may use in the future when you potentially take a data-related job. At the end of this class today, though, my main goal is for you guys to be able to translate either a question or a request that someone may make for you, and be able to translate that into a query that'll allow you to make a data-driven decision, or at least get to the first step of making that data-driven decision. And in doing so, today I'm also going to teach you guys how to copy tables from one database to another. The next class, that's when I'll actually teach you guys how to create these databases and these tables at source. And we'll also practice data joins, how we get data from other tables into a result set from another. We'll also practice merging and appending data sets as well. Class 3, we'll go more in depth on operators and wildcards for SQL. We'll talk about case statements and logical functions. And we'll also talk a little bit about how to clean and prepare data for analysis. Class 4, we'll talk about database modeling and entity relation diagrams. And we'll also talk about the differences between OLAP and OLTP data systems. Class 5, we'll talk about data storage, management, and administration, data governance and data quality, and data warehousing and business intelligence. So a lot of this should go in linear flow and build on each other. But today is going to be a brief overview about a lot of the basics. We'll talk terminology, syntax, and some of the best practices that you may apply in the coming future. And then class 6, our final class together, we'll bring it all together. We'll talk about how you can take data from a source, put it in a database, apply some basic SQL techniques to it, and be able to analyze your data and potentially even manipulate, create new tables, or delete tables. So let's do a brief introduction. What's data science? Why is it important? What is it? How is it used? Data science is the cornerstone of technology, science, and math, among others. It's everywhere. Just about every business and organization nowadays is looking for skilled professionals that know how to apply statistics, mathematical functions to data sets. Because more than anything these days, businesses want to be able to make data-driven decisions. And you'll hear that a lot in this class. Quite frequently, businesses flat out will refuse, or organizations will flat out refuse to make a decision without some sort of data to back that up, whether it's a raw data set or an aggregated data set or a summarized data set more specifically. Businesses really want to have that. And most importantly, businesses also want someone that understands the technical side, but the business side as well, or even understands what the business or organization's goals are. So you'll see all these different positions that encompass data science. Yes, we do have data scientists, but we also have data analysts, data engineers, machine learning engineers, business analysts, data architects, BI analysts, AI engineers, natural language processing engineers, and statisticians. All of these positions use data in some way or another, and they use databases and database technology to be able to collect answers, study them, and then provide those answers. Data science can also be broken out into a hierarchy of needs. A lot of you are probably familiar with something that's called Maslow's hierarchy of needs, which is where you have to satisfy the conditions at the base of your pyramid before you can satisfy any of the other conditions above those steps. So in data science, the hierarchy of needs maybe doesn't start with food, water, and shelter, but it starts with collecting data more than anything. We collect data from a number of different places. We can collect them from applications that are designed to record data. We can get them from sensors. After the Internet of Things came around in the 2010s, we have more data than ever and more devices that can collect that data and transmit it to databases for us to analyze. It can also come from other sources. We don't have to create or generate the data that gets used day to day. It can come from other companies. You hear frequently about examples of businesses buying and selling data. Well, this external data is a piece of that because some external data sources can provide answers to internal questions that maybe there isn't a data set to be able to analyze. So once we collect that data, the next thing that we want to satisfy in the hierarchy of needs is moving and storing this data. We want to make sure that data gets from source to database or even to a data warehouse as efficiently and as fail-proof as possible. We also have to have the infrastructure set up to be able to do that. And then there's things that are a little bit more advanced, like setting up a data pipeline or having an automated extract, transfer, and load or ETL process. And we can store structured and unstructured data. Structured data is going to be things that are defined and well known, kind of like a defined schema. When you think about an Excel table, that's an example of structured data because we know how the data is structured and what each column stands for and what each row represents. Because ultimately, data science is all tables, rows, columns, spreadsheets. It's just different techniques that you can apply to it that allow you to be dangerous, if you will, with data sets and data. After we satisfy having a good architecture, when we move and store data, that's when we can start to really explore, transform, and further our understanding of each of these data sets. So that encompasses cleaning data. There's plenty of examples out there of data sets where even just one word can be spelled wrong hundreds of times, but fundamentally that misspelling means the same. What if I told you that there's techniques that you can use to actually clean this data up automatically or quickly, that's much faster than doing it the manual way? These are the things that make data science unique. There's always new problems to be solved, but at the same time, there's probably been ways of solving it in the past. So it's being able to understand what the problem is, and then whether or not someone else has solved it before. And if not, being able to be unique in your thinking to be able to find an answer. After we explore and transform that data, then we start to aggregate it into analytics. This is what the big thing is. We want to analyze automatically some of the most important metrics that a business tracks. Think of revenue, sales, cost of sales, how much profit we make. In just about every job, there's metrics that help you understand if you're doing everything you're asked of. Those are things that can be measured. And in our world, just about anything can be measured. In fact, there's a book that I'm going to recommend to you guys at the very end of this that talks more in depth about ways that you can truly measure anything. Numbers, letters, characters, there's all very unique ways of measuring pretty much anything that you could imagine. But anyway, on to the next thing. After we do analytics, create metrics, that's when we can really start to optimize some of our techniques and get into the world of A/B testing, which is where we take one version of a website or a feature or even an application and then compare it to the results of a similar application, website, or feature. We compare those two and then figure out which version of that site performs better or leads to the most optimal outcome for either a customer or your business or you personally. And at the very tippy top, once we've solved all these other needs in the hierarchy, that's when we can start to get into AI, machine learning, deep learning, and really start to further our understanding of what this data set could do for us, or start to predict some of the outcomes that could come out of this. So the next thing that we'll talk about is some very basic data terminology. And stop me if you have any questions on any of these terms that I talk about. We start at the very top with the most generic term, a server. So what's a server? Server is a piece of computer hardware that can host databases, applications, and various other services that are accessed and utilized by either a person or a machine. Servers host a number of different processes. And when we talk about what an application or a process is, it generally refers to software, potentially combined with hardware, that processes and generates data that's stored in a database. This is what we'll eventually analyze, and these applications store data in a database. These databases are organized collections of structured information, data in the form of tables, views, and entities. When I talked about data mostly being like an Excel sheet, that's truly what data is. Data is multiple tables, and spreadsheets are a form of a table that have rows or records and columns that describe each of those records. Think of them like attributes. These tables are just documents and files. They are just like an Excel spreadsheet. When we talk about how these tables are organized by schema. Schemas will describe what the columns stand for, what data types are stored in these columns, and potentially what a record represents if you have things like a primary key constraint. And then the others are just very basic, columns and rows. Columns can also mean an attribute. These are things that describe a row or a record in a database or table. And then rows are the records. Rows are generally what you will analyze when thinking about how to measure something. For instance, if we wanted to know how many states were in the United States, general knowledge would tell you that there's 50 states in the US. But if you had a table that contained every single state or every single zip or every single town, there's most likely going to be a column that tells you what record that state belongs to, or what state that record belongs to. That's how you're going to be able to do analysis. And then a query is putting all of this together. A query is asking a database server how to get information, how to get data. And we'll talk a little bit more about how to actually format a query and how to get data out of a database. Any questions so far?
No, thank you.
3 miles away.
All right, we'll continue. So how does data flow? We just talked about, how data is organized and how data can progress, but how does data get from a source system, an application, software, program, even a person, all the way into analytics or AI or data science, most importantly? Data comes from a variety of different sources. We have things like OLTP databases, which are online transaction processes. These are things that like a bank might use to track transactions in a customer's account, or a business or a warehouse might use to track orders from a sale. And there may be hundreds of thousands, if not millions or billions of records that represent those sales or those transactions. That's what an OLTP database is. A lot of the times, these OLTP databases are referred to as source databases or source systems. And sometimes these can be proprietary to the business or the organization that you're working for. We also have things like enterprise applications and third-party data sources. So these enterprise applications can be customer relationship management tools, enterprise resource planning applications. They can be even accounting applications like TurboTax or QuickBooks if you're a small business owner. And then we have third-party data sources. We talked about this a little bit, but businesses and organizations buy and sell data all the time. There's a lot of things that come into play with ethics, how to handle that data, where that data comes from, what data can be shared. But more than anything, it's important to know that it is something that happens, and businesses will use this data all the time to help in their decision-making. All of these data sources then generally go through a process called ETL. ETL stands for extract, transform, and load. Oh, we'll go back. And occasionally, especially more as we go into the future, ETL is turning into ELT, which is extract, load, and transform. The difference between the two is that when you have ETL, you're actually extracting the data, and on that extraction, you're also transforming it to shape it into the table form that you want, and then loading it into your data warehouse in this case, or it can just be a separate database from where the data is originally stored. ELT is where you extract the data and then load that data into your data warehouse before performing any transformations on it. Data often does not come in the form that we like to analyze, or it doesn't come in the most perfect format. But most importantly is that data can be manipulated to be shaped in a way that is intuitive to analysis or even applicable to our use cases. And so that's where ETL comes in. More or less ELT, because we can extract data, load it into our data warehouse in its original form so that we don't lose the exact meaning of that data before we start to transform it. It also decouples the transformation process from the system so that if we transform something incorrectly, we can always go back and fix it and not manipulate its original meaning. There's plenty of other advanced techniques that we could talk about when it comes to ETL and ELT, but that's the basics of what that process is responsible for in the overall data architecture. We also have something called a data lake, which is sort of like a data warehouse, but the advantage of a data lake is that it stores all of this data from company or that a company generates or that they buy from another company, or that comes in from things like IoT sensors. And IoT sensors can collect tens of thousands, hundreds of thousands, even millions of records every minute, hour, sometimes a second, depending on the use case. And so that web or log data or other form of data that is generally stored in the cloud can be stored in a data lake and then retrieved later on. So you can think of a data lake as where all the water lives, and we may only want to take water from certain parts of that lake. That's where we would do ELT to pull data out of a data lake. There's also a concept that kind of combines these two called a data lakehouse, which is where all of your data lives on one platform in a storage bucket, if you will. And then that data warehouse can be built on top of the data lake to then reference certain parts of the lake or certain elements of the lake that you might want to analyze or that you can create value out of. But anyway, after that data warehouse is built, we can also data mart some of this data out. Generally, data warehouses are used to feed programs like Tableau or Power BI to visualize what's going on in a data set. But there's also multiple other cases for basically taking this data warehouse and putting it into other pieces. So you can create smaller databases out of that data warehouse called a data mart, where you only bring in the data that's relevant to that particular data mart. And some data marts are department specific, use case specific, analysis specific, even depending on the data sets and the use cases that you have. But each data mart can correspond to things like marketing or finance, or even HR. The use cases for a data mart could be that in our data warehouse, we have data that is sensitive. We could be talking about social security numbers or an employee's phone number or their home address or their checking account information if you work in like finance or payroll. And so that data might be valuable to HR, but it shouldn't be accessed by any other part of the company. This is where you can start to deploy custom data sets to every department in the form of a data mart for them to then use. And you don't have to worry about giving access to data to people that shouldn't have it, or data getting leaked. The thing that's worse, the worst part about all of this is that data can be leaked to outside sources. And the reality is that there will always be sensitive data out there. So it's up to us to be able to control what data is viewed by what person and when. Another use case is that data warehouses can create Excel spreadsheets or CSVs that can be exported and sent to people that maybe don't know the SQL skills that we're going to talk about in this class, but they know how to create a pivot table just like that, or they know how to run a column aggregate like a sum on a spreadsheet. I'm going to teach you how to do a majority of that in this class, hopefully, but just knowing that that is an option that's available is also important in understanding how data warehouses function and how each of these pieces play into one another. Does anyone have any questions on any of this so far?
Hey, Sam, can you explain the difference between warehouse and lake again?
Sure.
I guess I'm looking at it as the marts as being the foundation of the warehouse, but it's unclear to me how the lake and the warehouse differentiate.
Okay. So the data marts are derived off of the data warehouse. So those data marts will contain pieces of what's available in the data warehouse. But your data warehouse is going to have all of your important information that's been what we call modeled in the data warehouse. The data lake is going to be kind of a dumping ground for all the data that a business or an organization or a system might generate. And the data lake could have even more data than what is available in the data warehouse. And it could be that the data that's in the data lake, but not in the warehouse, isn't important or isn't valuable or doesn't provide us with exactly what we're looking for. But it could be valuable at another point in time. So we don't want to have to delete that data or lose its insight, but rather have it available in storage for another time. And then if we find a use case, that data from the data lake that isn't in the warehouse could be loaded into the warehouse. And then, like I said, those data marts are derived off of the model data that's in the data warehouse and then distributed to the areas of an organization that need it the most. Does that maybe clarify things a little bit more?
Absolutely. I guess I was getting hung up on the visual of the lake being a smaller subset. And the warehouse obviously is, yeah, I was just getting confused, the visual, putting on a derailment there. Thank you.
Yep. Any other questions before I move on?
I'm still stuck on what actually Ryan was asking. Can you give just an example, like a real life example of how you would explain that, the data warehouse and the data lake, just so, because I think I got stuck where you said like information may not be a data warehouse because maybe it's not relevant to have that data there, but data lake, you might need that information from data lake. So just, could you give me an example of how, like, what that look like in real life in a company?
Okay. Let me think about how to maybe apply this to you specifically. So when we talk about budgeting, maybe a data lake could contain every transaction that you've ever made on every credit card, debit card, checking account that you've ever had. Let's say in an ideal world, you had the ability to export every transaction you've ever made from all your checking accounts, all your debit cards, all of your credit cards, and put them into one place. Just dump them into a basically unmodeled data store. That's what a data lake would be. It's where all of your data sets that you could ever possibly access would live. And then your data warehouse might only be applicable to like a debit card, for instance. You want to see how your cash comes in and where your cash goes out. And so the data that you might want to use could exclude credit cards, but only include your debit card transactions or your checking account transactions. And then you could further break out that data from those sources into other derivatives of that information. So if we had information on your transactions, we could see what stores they were purchased at, and then create another table that lists all of the stores that you had transactions with. We could also categorize what the transaction was. Was it for groceries? Was it for car maintenance? Was it for entertainment? These are all the different things that you could model out, but your individual checking transactions or debit card transactions or credit card transactions might not contain that data. And so, this is a little bit more advanced than what we've gone over so far, but what you could do is you could write a script that then goes through every single one of your transaction titles. And then based on what's in that transaction title, you could derive what the category was or what the purpose of it or purpose for it was, or what type of or how big of a transaction it was, and group them into groups. Probably not the best example, but just trying to give you something that's a little bit more familiar. But think of it like this. A data lake is where all of your data lives. Data warehouses will contain all of the data in its most analytical format. And then data marts are only going to contain the parts of your data that are applicable to your analysis. Does that make a little bit more sense? Hopefully.
Yeah.
So are you saying like the data lake is everything? The data warehouse is kind of like a warehouse where everything is kind of like organized up in different sections, almost like a library. And then the data marts would like pretty much only pull the relevant information from that library that you need?
Yes, that would be actually a really good example. If we use the library example, you can think of a library as having sections, right? The data lake could represent a library where you have all of your books and all of your computers and all of your resources that a library might have. And then the data warehouse could be organized into sections. Say we have a fiction section and a nonfiction section. And then for each of those, not fiction and nonfiction, we have multiple subgenres. So we've organized it based on what books are there or what devices are available. And then the data mart, you could think of it like, like kind of like maybe a checkout system. This is a little bit on the fly, but you're on the right track with the library example. The data lake is everything. The warehouse organizes it, and then the data mart segments every single one of those groups of data.
Oh, okay. Thank you.
Any other questions before I move on?
Just the lake house, and I hate to throw that in there. So help me kind of understand the lake house part of it, which isn't depicted here. If you would.
Okay, so the lake house concept is still relatively new. And like I said, it's like combining the data lake or the best features of a data lake and a data warehouse. Traditionally, data warehouses, you would have to extract all of your data out of your source systems and then put it in your data warehouse and then remodel it. And the bottleneck was generally being able to process that data every single time. And so now that data comes in such large quantities and there's so much data out there, the need for having a data lake or a decoupled storage solution has grown immensely. And so what a data lakehouse does is it allows you to query your massive data lake, every single piece of data that you've ever had. And then on top of that data lake, you can kind of create a library where you start to organize what all the elements in your lake actually represent. And then you can continue to segment that out into data marts or individual data warehouses if you really wanted to. But the idea is, instead of having two separate systems where you have a data lake that stores all of your data, the data warehouse where you store all of your valuable information, and then your data marts where you distribute that to the people who need it, you can have all of that on one platform where you can query all of your data, create value out of it on top of that data lake layer, and then distribute it out to customers or even your clients.
Cool.
I know it's not depicted. I hesitated bringing it up, but it is something that has really come out of the woodworks for the data science field, especially in the last several years. So it's important that we discuss it and talk about some of the advantages of doing so. But that's not to say that this kind of an architecture isn't good enough. In fact, this is the tried and true method for getting data from an application or a source and then measuring it, giving it value, and then providing that value to others. But anyway, that's enough about data lakehouses, warehouses, and data lakes. Let's move on to the next thing, SQL. It's what you're all here to study. So what is it? I decided to use ChatGPT for this, and I asked it, can you tell me what SQL is in less than 100 words? And this is the answer it came out with. SQL, or Structured Query Language, is a programming language used to manage and manipulate relational databases. It's used to create, modify, and query databases to retrieve, insert, update, and/or delete data. SQL is supported by most relational database management systems and is a standard language with a specific syntax and set of rules. So SQL, in even less than 100 words, is a programming language. That programming language is just like other languages, English, French, Spanish, Japanese, Chinese, anything that you could potentially think of. That's what SQL is. And more than anything, like I talked about in the intro, what I want you guys to be able to do by the end of the class is to think about how to translate a question into something that could return a data set for you. But what you should know about SQL is that there's many SQL-related database platforms today. There's MySQL, which we're going to use in this class as an example. There's Microsoft SQL Server, which it sounds like a couple of you are familiar with from your job. There's also Oracle, which I'm not personally a fan of, but plenty of businesses use Oracle databases today. There's also Postgres, IBM DB2, and plenty of other examples. With the explosion of SaaS companies and the explosion of new software, especially AI, machine learning driven software, there's more and more programs that are coming out today that you may use either in your job or in your free time that actually look at databases data and allow you to aggregate it and return results that can be usable. So next thing that you have to understand is that servers can be run locally, on-prem, which is kind of another word for locally, but you'll need something like a VPN access, or virtually in the cloud. We, in this class, are going to use virtually in the cloud instead of on-prem or locally. But the reason that I want to bring these up and describe them and differentiate them, most importantly, is that a lot of businesses, especially before the age of modern cloud technology, were all running their databases on-prem. Their businesses would hire database administrators to set up a server on a local machine, like a desktop, and probably not a laptop. But nowadays you might be able to use a laptop if you have the right use case. But those desktops would then connect to the internet, and then anyone that had access or knew how to access that server could then go on and query data like they would normally. And then there's on-prem databases, which are exactly that. It's the local databases that these companies created. I guess maybe I'll differentiate that a little more. When I refer to locally, I'm talking about on your machine. You can create a server or a mock server and then run any of the SQL commands that you normally would here in MySQL Server on that server. Virtually in the cloud is sort of like on-prem, but not really. When a database server is run on the cloud, it gives you a lot of versatility on where you access it from, the speed at which you can return results, the amount of data that you can store, because the benefit of the cloud is that storage and compute, which are the two important elements of handling data, managing data, and manipulating data, can be scaled dynamically based on your usage. So if you have a small data set, maybe less than 10,000, 100,000 rows, and you're the only one that accesses it, you probably won't need the same amount of compute or horsepower that like a larger business might need that's trying to analyze real-time data on their website, for instance. So you can scale that to your particular use case, and your costs also scale, which is why it's very important for businesses to think about transitioning into cloud computing, because no matter what, you don't have to manage the amount of compute you have until you actually hit the cap. You can also set it dynamically so that it adjusts without even having to worry about it. If your use case changes, the cloud will also update those kinds of things for you. And last but not least, why are we learning SQL? Why not Python, or why not another language? For data, SQL was developed in the 70s, and it was commercially available to customers and individual users since 1979. So SQL's been around for, 30, 40, almost 50 years, or coming up on 50 years. There's not a lot of programming languages that have been around and active for that long. So what I want to emphasize is that SQL's been around for a long time. There are a lot of resources out there, and there are a lot of people who've dedicated their lives to learning SQL and teaching SQL. And since it's been around that long and it's still in its peak, it's probably going to be around for much longer. So it's definitely an important skill to have. And I think before we actually get into SQL commands, we'll probably take a break. So we'll take probably a 10-minute break if everyone's okay with that. And we'll return at about 7:10 Central. Does that work with everyone?
It does. Thanks, Sam. Already very informative already. Thank you.
Awesome. Well, we will return here in about 10 minutes, but until then, I'll talk to you later. All right. Hopefully everyone is back and ready for hour number 2. Are we ready?
Ready.
I got one ready. I don't know if I can go without everyone being ready.
Ready.
Ready. All right. I'll just assume that everyone's here and ready to go. So let me share my screen and we'll get going again. Also, if my calculations are right, which sometimes they are, sometimes they aren't, we should definitely be out of here early tonight. But feel free to stick around. Like I said, there will be homework. Can't be class without homework or a quiz. I chose homework. But if you want to stick around, I'm more than happy to help all of you along with the homework. Try not to give you answers, but help you guide you along the way and answer any questions that you might have.
Awesome.
All right. So we left off here with what is SQL? We asked our friend ChatGPT to give us an answer on what SQL could be defined as. Next, let's talk about some SQL commands. There are tons of SQL commands out there, but they are all encompassed within 4 different subcategories of each other. We have data manipulation language, or DML, data definition language, or DDL, data control language, DCL, and transaction control language, which is TCL. And you'll notice that those top 2, data manipulation language and data definition language, are both in a different color than data control language and transaction control language. This is because for simplicity's sake and for brevity for you guys especially, this class, data manipulation and management, is only going to deal with data manipulation language and data definition language. Those 2, data manipulation language, you can think of that as being able to perform what's called CRUD operations. And no, not CRUD like, oh, CRUD, this happened. It's CRUD as in create, read, update, and delete. The 4 most common commands that you'll most likely encounter in your data career, and especially just overall in data. These are the types of commands that will actually allow you to manipulate data, like DML stands for, or even read data from a database. Some examples of DML are select, insert, update, and delete, which are nearly identical to create, read, update, and delete. You can think of create as insert. You can think of read as select. You can think of update as update, and delete as delete. But that's how all of those play together. And then we have data definition language, which is actually going to describe the data that you're working with and tell you how a particular object is organized, which is the definition of a schema. Some examples of data definition language are create, alter, drop, and truncate. Create will allow you to create a new object. Alter will allow you to change something about an object. Drop will completely drop things out of the table. And then truncate will actually remove the data from the table before you load new data in. Drop is the subject of a lot of controversy because without the proper security permissions, like we've applied to the databases and the data sources that we'll work with in this class, if access is given to the wrong person or is put into the wrong hands, anyone with the proper credentials could theoretically drop everything out of your table or database with one simple command. And so that's the reason why people like database administrators have a very important role in the data lifecycle, because they are the gatekeeper. They're the ones that make sure that data is secured safely. It's only accessible by people who can access it, and it can only be updated by those who have the proper permissions. But database architects, or DBAs, even administrators, are not as concerned with DML and DDL, although they will use them usually in their day-to-day. They're more concerned with implementing DCL and TCL, which are how we control that data and access to the data, and how we can actually control various transactions or versions of that data in the event of our tables getting dropped or a server going down, or if you have on-prem databases, that server failing altogether and losing your data. In the cloud, with that transaction control language, you can actually create versions of your data or like save points, and you can actually roll back or restore versions of what your data was at a point in time if something catastrophic were to occur. And then in that data control language, that's where you can actually assign permissions for other users. You can define whether someone can select data from a database or read data from a specific data set. You can control who can update it, who can delete data from that table. Anything in the CRUD operation can be controlled using data control language. On to the next thing, which is SQL data types. A lot of people, when they're talking about programming, think that programming languages or computing all boils down to ones and zeros. And while theoretically that can be true at some point in the funnel, it isn't just ones and zeros. But there are a few ways that you can lump all of these different data types together. We have strings, we have integers or decimals, which are numbers. We have dates and times, and then we have Booleans, which are your more traditional ones and zeros in programming. They're the ons and offs of SQL. So let's talk about each of these. What are strings? Strings can be anything containing the characters A through Z. They can also contain any number from theoretically negative infinity to positive infinity, even though infinity is an undefined number. But you can see over in the spec columns on the data types chart what values are possible when you store data in SQL. So, like for example, int is one of the most common types of numbers. You can only store, I think it's negative 2.1 billion to positive 2.1 billion, and that's just the limitations of the system. But you can always go even higher than that based on the storage. But it is important to understand that the more data you store, the longer data you allow, the more space that it consumes. And storage in a cloud environment, while theoretically infinite, is not. There is a finite amount of storage that exists. And part of being a data analyst or a data scientist is being able to balance delivering results with a large data set or population with having something that is storage efficient and easy to retrieve from the database. But those are topics for another time. Those are more advanced than what we're here to talk about. But strings, back to strings. Strings can be characters A through Z. It can be a number. It can be special characters. For instance, emojis. Whether you believe it or not, emojis can be stored in a database. They're stored in something called Unicode, and you can store any of these emojis in Unicode in a database, and then you can have the front end retrieve the string with a emoji and then translate what that Unicode is to the front end user. Then we have integers and decimals, which is what I was talking about before. These are numbers, but more specifically, special classifications of numbers. You'll notice that the difference between integers and decimals are that integers are generally whole numbers, but decimals provide that precision that so oftentimes we want in metrics. When we talk about things like conversion rates, if I were to use a website, for example, and I wanted to analyze how effective a marketing campaign was, I might count the number of emails that we sent out for a particular campaign. And then after that campaign, we might want to analyze the number of hits that the website received. And so when we figure out the conversion rate for a number of individuals that received the marketing campaign over the number of individuals that visited the site as a result of that campaign, it's going to be one number divided by another number. And it may not always be even, but being able to compare that if you have multiple campaigns is what makes these decimals important, especially over an integer, because you can get down to an even more granular level than just an integer and see what the exact precision comparison is between two separate records or two separate groups of data. Next thing is dates and times. When you deal with data, you'll notice that data is frequently stored in varying formats, but it all comes down to knowing that data is classified in years, months, days, hours, minutes, and seconds. And then you can aggregate upwards or create new conditions based off of those years, those months, or those days. You can also do math on these dates and times. You can take two date values and compare them. You can figure out which date is the most recent or the oldest. You can take the difference between 2 days automatically with one simple SQL command where you say, give me the difference in dates between date A and date B. And you can also do time math. For instance, if you're given two values in SQL that are stored in hour, minute, second format, you could actually take the difference between those two with another one-line SQL command, and it'll tell you how much time has elapsed between those two values. And then we have Booleans. Like I said, these are your classic ones and zeros in computer programming that many of us think about when we talk about programming languages. Booleans can be stored as a true or a false, or they can be stored as a 1 or a 0. These are also frequently referred to as a flag or a bit flag in a system. And you can use it to indicate whether a condition was met, or if you want to add like case statements, for instance, you'd be able to use Booleans to tell you whether or not the case statement generated the proper data. So there's plenty of ways that you can use these data types, but understanding what data types you'll be using will help you in understanding how to measure data going forward, because any data that you bring into a database will generally be defined. When you declare your schema, like we talked about in the terminology, your schema is going to tell the database engine how to actually format this data table. So you might call a table, let's say like sales, if you wanted to look at a sales table or a sales process. Of those sales, you might have an identifier, which could be indicated by either a string or a number. And then you'll have a title of that sale. Let's call it target order on 3/15/2023. And then you might have other attributes that relate to that sale, like what item was included on, or what was the most frequently purchased item. Or if we went down to an even more granular level, and we said that each row indicated an item that was sold to someone, that row might contain a value for the customer that purchased that item, the item that that customer purchased, when that customer purchased it. And if we have information about a customer, we might be able to pull in information about that customer, like the zip code that they live at. And then we could compare it to the zip code of the store and figure out where our customers are coming from, or what zip codes or areas a particular store is most frequented by. So these are just some examples of how you could implement things like strings, integers, dates and times, and even Booleans into a practical example. Any questions on data types or how data types can be interpreted in a database?
Nope, straightforward.
All right.
Got it.
All right. We'll go on to the next slide. Next thing is common SQL functions. So functions are what you can actually apply across a column. So when we talk about a data table and drawing insights, we know that tables are made up of rows or records and columns or attributes. So when we run functions, we generally run these functions on a column, but they are across all rows in the data set that you return. So there's multiple types of SQL functions out there, and I have links to all of these that will actually give you examples of how each of these SQL functions can be used in a practical setting. But the main types of SQL functions that are out there are aggregates, strings, control flows, date and time functions, comparison functions, math functions, and conversion functions. And I'll go into each of these individually and talk about why they might be useful or how we could use them. So aggregate functions are going to be some of the most common functions that you'll use as a data analyst or a data scientist. And even as a data engineer, what does an average function do? It scans your entire table, all of the rows in the table, and then based on the column that you select, it will return the average value. So that means that the average value or the average function is anticipating a number. So this means that when you run an average function, you can only run an average across a column that is formatted in the schema as an integer or a whole number. Same goes for count, sum, min, or max. But when you count records, all we're doing is we're saying count the number of rows in this table. And then you can further apply aggregates to this. Like if we were looking at a sales table, for instance, and every row in that table represented an individual item that was sold, we could count the number of items that were sold and then group it, which is something that we'll get into in a few slides, by the store that it was sold at. So when an executive wants to determine how their products are performing at each of the individual stores or locations, they might run a count on all of the sales in the table that occurred by store, or they could do it by state if we know where the store was located, or we could do it by a customer's location if we wanted to analyze what geographic region our customers most frequently buy from. And then sum, min, or max are a little bit different than average and count, but sum is going to just add everything up that you have in a column that you define. So an example of this, if we use our sales example, is if I wanted to sum the number or the amount of revenue that each of these sales produced, we would be able to run a sum across a product price column, or even a gross price if we wanted to include the taxes and fees and other additional line items on a sale. And we can sum all of this across. And then we could even group it further by seeing how much revenue was generated by a store, how much revenue was generated by state, how much revenue was generated by a particular customer even. And then further on down the line, depending on how rich a sales data set is, it may even contain information on how much that item costs or how much profit a sale could generate. You could run a sum across each of those columns and you could say, what was our total revenue? What was our total cost? And then what was our total profit? And we could break it out by any other attribute that's in that table. And then the min and the max are a little bit more straightforward. Min will return the minimum value based on your grouping. So let's say you had a table of sales and you wanted to find out what the lowest profit margin item was. If we have a revenue column, a cost column, and a profit column, we could just take the min of the profit column and then and then we could return the entire line for that particular item. We would know more about it. We could know what manufacturer made the item that's the lowest profit, or if we wanted to find our items that had the maximum or that had the highest revenue generating potential, we could just run a max across the revenue column and return the item return the value of the most revenue or the highest revenue generating item. Then we have string functions. We have concatenate, length, and trim. These are all also very important. Concat or concatenate concatenate is the long form for concat. Concat is specific to MySQL Server. But what concatenate does is it allows you to add the results of strings together. So if we had, let's say, a customer record and we had a first name, a middle name, and a last name, and we have a date of birth and we have a current age, we might want to concatenate some of these columns to provide value to another person. And let's say they wanted a single column that contained the full name of the customer in addition to their birth year, for instance. We would run a concat statement, and then each of the arguments that we gave in the concatenation statement would be the column names that we wanted to add together. So if we wanted the first name and the last name and the date of birth, we would do concat, and then in the parentheses, first name, comma, last name, comma, year. And then if we wanted to add additional arguments like spaces or hyphens to that string, we can also do that in the concat statement pretty easily. The length statement will actually, when given the argument for a column or a value, will return the length of that string in number of characters. So if we think about the word data and we gave the length function the argument of data, just the 4 letters of data, length is going to count the number of characters in that particular value and return it. So in this case, length of data equals 4. And the trim function is going to do something that's a little bit more powerful for data cleansing, which is it'll actually look at the value that you provided. And if there are preceding spaces or spaces on the outside of a string, the trim function will automatically remove that if you define it. The next thing that we can discuss are control flows. Case statements are one of the most frequent functions that you'll probably use when cleaning data. What a case statement allows you to do is define a rule that you might want to translate data for. So if we had, let's go back to our sales example. If we have a table that has rows for every transaction made, we might want to know what color of items are being sold at this store. And so let's say we don't have information or data on the type of product that was sold or what the color of that product more specifically was. If we knew with our intuition, or if we had been working in a warehouse or with this company forever, we could probably look at the list of items that are sold and know exactly what color they are. So what we can do is we can actually create a statement where we start it with case and then basically give it computational arguments. When this column equals a certain product name, then say that it's a red, say that the product color is red. Our case statement line would say when product equals product name, then red. And then if you have other products that are also red, you could add additional lines for every single product name and then give them a color name in the case statement. And then this case statement will return one column that will match the criteria that you give it row by row automatically. So even if you had a sales record, or even if you had a sales table of 10 million rows or 100 million rows, if you only sold maybe 10 different products and you knew what color each of those 10 products was, you could easily make a 12-line case statement that then translates the color of that item based on its name or the string given. You can also do multiple conditions and add on to each of these case statements. So for example, if you have 2 of the same item from a supplier, or you're trying to sell 2 of the same item, but they come in 2 different colors, you could actually add an additional criteria on it and say, when the product equals this product name and the shape is circle, then it's red. But if it's a square item, we might say that it's blue. And you would be able to go all the way down to an extremely granular level to get the results that you want, instead of just doing an encompassed value. Next is if. If is a very easy function to understand. It's if case, then this. So if the case is met, then the value will be returned that you defined. And then if null is if the value is unknown or the value does not exist, then you can give it basically like a control flow. So if it's null, then you can query the item provided, or you can give it the value that is necessary. The next thing on the list is date times. We have cur date, which is current date, date diff, which is the difference in dates, date add, which is adding or subtracting days from a given date, of course. And then you have day, month, and year functions. We'll start with current date. What does current date do? Current date will give you exactly like it says, the current date in the standard date format. So a common case that you might use this when you're doing analysis is if you wanted to see everything that occurred before today. So an example is if you have, say, like recruiting, for instance, when an employee gets recruited by a recruiting firm, there's different steps of the process. And occasionally a recruiter might know when a future event might happen. And they'll put into a column that the event is going to happen on a date far in the future. The benefit is that since it's stored there and we know what date it was, we can look back in time and see all of the other records that also happened before that particular time. So if we wanted to return all of the employees that were that started their contract positions before today, or anyone that has begun their contract work, we would select all of our employees from the table that contains all of our recruiting data, where the start date for the employee is less than or equal to cur date. Cur date will give you that current date dynamically instead of requiring you to type in the date in the properly formatted function. The next thing is date diff. What does date diff do? It gives you the difference between two dates. So if, for instance, you were running this recruiting firm and you wanted to see what the lag time was between prospecting a potential recruit to actually getting them signed up, to finding them a new position, and then them starting that position, you can use the date diff function to actually find out what the amount of time was between each of those steps. And then en masse across all of your employees that have been recruited, you could then calculate the number of days between each of those steps. So you can see how this can start to become a little bit more powerful when you do something that's called value chaining in data. Value chaining is referencing any point of a process or any point of a business that either provides value or allows you to proceed to the next step in a process. And a lot of the times businesses want to understand what their lead times are. Another good example here is when you want to determine how many days are between the lag time between potentially a retailer ordering products for their store and then those products arriving in their store. If you measure that maybe even week over week or month over month, if you start to notice that those date differences start to rise, you might start to question your supplier or try to understand why there's increasing lead times to get your products. So that's just a couple of examples of how date diff is valuable. And then date add, it allows you to add dates to each other. So this one's kind of straightforward. If you want to add a week to a particular given date, all you would have to do is select date add day as your first argument, comma, your second argument, which is going to be your amount of days that you want to add. And then your third argument is what date do you want to add these days to? So if we were looking at today and we wanted to figure out what the date is going to be in 160 days, which, it's probably not very easy when months only have about 30 days in the year, you'd easily be able to do this. And the computer will know exactly how to do your date operation. You can do date add, day, comma, whatever number you want. Let's make it something even crazier. Let's do something oddly specific, like 167 days. All you'd have to do is type in 167 as an argument, comma, and then put in the current date. Or you can use cur date as an argument in your date add statement. And that will add 167 days to the current date and return you the exact day of the calendar year that is 167 days from today. So you can see how a lot of these are very powerful when it comes to understanding your data and being able to measure it. Next thing is day, month, year. You may not use this as frequently, but if you wanted to analyze, if we go back to our sales example, what day of the month was that led to the highest number of sales, or what month of the year your highest sales were, you'd be able to use the day, month, or year function given a particular day. Okay, maybe that's not the best example, but what day, month, or year will give you is the exact day or the exact month or the exact year of a given date. Day will give you the number value. I believe month gives you the text value, and then year will give you the number value. The next few sections are a little bit more complicated. So I just want to stop here and let you know that aggregates, strings, control flows, and date and time functions are going to be some of your most frequently used SQL functions in a data analyst or a data scientist career. We use these extremely frequently, and they do each have their own set of values. But I did want to spend quite a bit of time on each of these so that you could have an example of how each function may be used in a practical setting. So the next couple I'm going to breeze through pretty quickly. Comparison functions, coalesce, is going to take the first non-null argument among multiple columns. So if you have 3 columns that represent relatively the same thing, but there's small differences between each of them that are important in understanding that process, you might want to coalesce all 3 of those columns together into one. And you'll provide in that coalesce argument or that coalesce statement each column as an argument. So if you had 2 columns that you anticipate to be null in a case and a 3rd column that you want to use as a default, you would do a coalesce across column 1, then column 2, and then column 3 that you know won't be null. And even if it's null, you could add a 4th case that either provides a 0 or just leaves it as null or provides it a unknown error string. The possibilities are endless there. And then is null is just going to do an operation on a field. And if the field is null, it's going to return a Boolean value, a true or a false. So you could also use is null as a control flow function if you wanted to. Next is math functions. When you want to round a decimal to the nearest integer or whole number, round is going to allow you to do that. So in the round function, you'll give it an argument of the column name that you want to round. Truncate is going to, I believe, drop, and then absolute value is going to provide the non-negative value of any number you give it. So if you provide a column name that has potentially negative values, it'll return the positive value of that column value or that row value. And then conversion functions, in the event that data is not perfect, which totally never happens. That was sarcasm, by the way. Oh, sorry. You'll be able to use the format or the cast functions to actually format your data into a usable format. So sometimes you may have a column that schema defines as a string, and every single value in that particular column is actually a number. What you could do is you could format that particular column as an integer or as a big int or any of those integer or whole number or data classifications could be provided as an argument in your format or cast function. So it allows you to be a little bit more versatile with your data, even if it's not provided or formatted in the function that you want. Any questions on these SQL functions before we move on?
No, it's just a lot of information to learn.
Yes, it's a lot of information, but just having a list of a lot of these common functions will be valuable. And I know that there are a lot of examples that I just gave there, but thankfully this is all recorded, so you'll be able to go back and listen in again to some of the explanations. And there are lots of resources here that you'll be able to use. And MySQL tutorial will also show you some of the real life examples of like how you might use this or how you might interpret this function. So we'll go on to the next one. These are SQL operators. I'm not entirely sure if you guys got to this section in the previous class, but to go over them quick, SQL operators are anything from arithmetic functions to bitwise functions, comparison functions, and logical functions. The most common ones that you'll use are arithmetic, comparison, and usually logical. I typically don't use many of the bitwise functions because A lot of them are also encompassed in these logical functions. You'll notice how the ampersand, the pipe character, and that was, I think it was supposed to be a pipe and a minus for exclusive OR, are also similar conditions in logical. So instead of an ampersand, you can type and. So when you write out a SQL query, you don't have to think about what character corresponds to and. You can just type and. Or you can type or. That's another option. But to go from top to bottom, arithmetic functions allow you to add, subtract, multiply, divide, or modulo. And modulo is not as important, but as long as you understand add, subtract, multiply, and divide, you'll know enough to be dangerous. You can use add, subtract, multiply, and divide functions across multiple columns. So let's go back to our sales example. If you wanted to add another column to your table, let's say you didn't have a profit column, but you had a revenue column and an expenses column, you could actually create a new column that is the revenue column minus the cost column, and you can call it profit. So it's an example of being able to use your other columns in your table to arrive at an answer, so long as you can do pretty basic math. Bitwise functions are going to be your ands, ors, and exclusive ors. You'll generally only use ands and ors in a lot of your clause statements. And we'll skip down to logical because I think this feeds really well into this. Your logical statements that you can use in line are things like and, between, exists, in, like, not, or. There's plenty more. I think there's 50 plus different logical operators that you could possibly use. But I just chose the ones that are the most frequently used. And is going to allow you to attach multiple conditions to something that you're computing, whether it's a column or a row value. You can apply multiple different conditions using and on top of each other. So if we go back to our example with a retailer and we have products that we're trying to classify, but we don't have their color. If you knew that only circular shaped objects from a supplier were red and square shaped objects from another supplier were blue, you'd be able to write a condition that says where the supplier is ABC and the shape is circle, then red. When the provider is ABC and the shape of the product is square, then blue. It's an example of how you can use additional logical operators to derive what a data value might be or what it should be. Between is generally only used for days. So let's say you wanted to return sales that were between two very specific days. Instead of writing out a column is less than or equal to a date and a column is greater than or equal to the lower date, you could say where the sale date occurred between date 1 and date 2. And that would be an example of applying multiple logical operators in a single line of SQL. I think I'll skip exists. In is going to allow you to define multiple conditions. So let's say, and this is going to be probably a homework example. Let's say you wanted to only return data for 2 or 3 states out of a file that provides every zip code, every town, every city, and every state in the United States. You might only want to return a subset of those states. And if you wanted to return the whole data, you'd structure your query something like select star or all data from your zip code table or your state table or your city table, where the state is in, and then in parentheses, actually define each of the states that you want to return. So if you only wanted to return, say, towns in states that surround Nebraska, we know what states surround Nebraska. It's South Dakota, Iowa, Missouri, Kansas, Colorado, and Wyoming. We could add in that in statement every state that I just mentioned. So we could say where the state is in Nebraska or Colorado or Kansas or Missouri or Iowa or South Dakota or Wyoming. I can't remember if I mentioned Wyoming. Everyone always forgets about it. But that's an example of how you would use an in statement. And then a like statement. In a like statement, you'll generally use this when doing something called data mining. So when you have data sets that you might not know what's included in it, or you might not know what all of the values are, and you're trying to search for something specific, you might know what the first few characters are, but you might not know what the whole string is. So for instance, if we wanted to search all of our transactions where the provider name started with an A, we would select star or select all from our sales table where the, call it supplier name is like, and then an A. And if we wanted to return every supplier that had an A in its provider name, then we would put a percentage sign on each of those, or on each side of the A. So your SQL query would look something like equal or like, and then in that like an A or a percent, and then an A, and then a percent. But we'll walk through some examples so that makes a little bit more sense later. And then the comparison functions, very similar to entry-level math. We have equal comparisons, greater comparisons, less comparisons, less than or equal to, greater than or equal to, and then not equal. When you want to compare values, you can use the not equal to return everything that doesn't match. So when you do the not equal, it's just the less than and the greater than sign put together. I think that's all I want to cover there. Any additional questions on operators?
Nope, thank you.
So what you're saying is, instead of typing out and, I could just put an ampersand in.
Correct.
And a lot of people don't like those shortcuts.
I would say it's personal preference. Personally, I like to type my SQL out pretty similar to plain English, especially in my role when I'm communicating to business leaders. If they asked me, how I got to a specific answer, they could interpret the ampersand or the and, but when you read it from left to right, it's almost like reading a sentence out of a book. So I prefer using and, but it's totally up to personal preference.
Just wondering. So thanks.
Yep. Any other questions? All right, we'll go to the next slide. Now let's talk about putting this all together. How do we formulate a SQL query? There's two different classifications of creating a query. You can create a basic query that generates something like a list, where you return columns from a table, but you don't filter out any results. And then we have an aggregate query syntax where we generate groups of data. So if we use, before we get into that, you'll notice that I have rows on here that are indicated as required, and I also have rows that are indicated as optional. When you create a basic query, the minimum amount of arguments that you need to return a database, or not a database, a data set or a table of data are indicated there. You have to select either all of your data, star, or distinct, you either have to select all of your data, which is returning duplicates if there are any, or you select distinct data if you only want to return unique results. Then on the next line, you return the actual columns that you want to analyze. So if we think about a sales table, if we only want to return the store that an item was purchased at, the item that was purchased, and then the color of that item, we might only include the store name column, the item name column, and the location of the store. We can continue to add as many columns as we want. And when we get to table joins, you can even select columns from these other tables that relate to the data that you're querying from at base. And then the last item that's required is from the table that you want to query. So think of it like this. The most important part of the SQL syntax that you have to memorize, or that's at least helpful to get you started on a data science project or even analysis project, is select star from table. That will by default return every column in your table that you're asking the database to return for you. And then you can add, additional arguments onto here. So if you only wanted to return rows where the product comes from a specific supplier, you could add a where clause and you say where the supplier equals the supplier name. And then the last part, which is also another optional piece, is you can limit the number of rows that are returned. Let's say you are doing a data mining project, which is where you don't know what's in the data set and you're trying to understand better what data is contained in this table, what rows and what columns. You might only want to limit the first 1,000 results if you are querying against a table that has tens or hundreds or potentially hundreds of thousands or millions of rows. This allows your database engine to not get overwhelmed and allow others to use the database if you're running a very long query. This allows you to start to learn about the columns that are in the table, learn about what each row represents, find trends or things that you see frequently in each of the rows of data. And then moving on to aggregate query syntax. This is where you actually can generate groups of data and start to create more robust data sets that you can analyze. You still have some things that are required, the select and then the columns and then the table that you want to define, similar to the basic query syntax. But another thing that you have to add on when you apply an aggregate to a data set is a group by column. And what you're going to group by is every column that you're selecting in your select statement other than the aggregate column. So let's say we wanted to return the population of every state in the US. What we would do is if we have a table that has every zip code or every town name and a population associated with it, we would select the sum of the population column and then the state abbreviation as our column 2 from our zip code table or our state table. And then we probably don't need to add a where column because we want to return everything in our data set that we have. And then we want to group it by the state because that's our column outside of the aggregate function that we're applying to the data set. So we would group by state name. And then we can run that query and it'll return the total sum population of every state. And it's going to group it by state and return it to you. And then we can add some additional columns. So let's say we only wanted to return states who had a total population or a sum population of over 1 million. I think this only excludes Wyoming and maybe Vermont and Maine. But what that would do is when you put a having sum of population less than the certain number, it allows you to eliminate results that either aren't relevant or aren't applicable to the data set you need to pull. And then another function that you can add on is an order by column. And you can use this order by column on the basic query syntax as well, where you return a list. Let's say you return a sales record and you wanted the entire sales record to be in order from newest transactions to oldest transactions. You would order that by the transaction date and then in descending order because we want to return the most recent records first and the oldest records last so that we can analyze what our current state of affairs is and then see how it changes over time potentially. And then we have our limit function. So that's, again, optional, doesn't need to be included, but since it's there, you can also only return 1,000 groups of data if you wanted to. Or if you only wanted to return, say, the top 10 states in order of population, you'd be able to limit 10 results. Any questions so far on how to formulate a SQL query or how we've dissected formulating these queries?
I think the questions will come once we put it in,
All right.
in practice for sure.
All right, sounds good. Well, I think we're almost at 2 hours now. The next slide is some of the things that I've already talked about. So let's go ahead and take another 10-minute break, and then we'll come back and we'll start working through some of the exercises and homework. And hopefully we can even have a break here, or not break. We can break early for the day. How does that sound to everybody?
Sounds good. Thank you.
We will see you all in about 10 minutes. All right, everyone. Hope you're all back. We only have a little bit more to go through, and then we'll sign off for the night. How does that sound?
Sounds good.
All right. Well, let's get to it. Start sharing my screen again. And we'll start from where we left off. We just learned at a basic level how to formulate a SQL query. But what we're going to do now is we're actually going to start to get into the data, and we're going to start to apply our skills. And I have plenty of examples for us to talk through. And I will also send out the homework assignment for tonight so that you guys don't have to type all the answers. It'll be frameworked out for you. And all you have to do is the fun stuff, writing the queries. So before we get there, let's talk a little bit more about querying data using SQL. Like I said before, the most important syntax for you to remember and memorize is select star from table. It'll allow you to return the entire data set and then start to filter it down to exactly what you need later on. The English translation for select star from table is just give me data from these columns stored on this table. And like I said there, manners are not required. You don't have to say please. And when you get a data set back, you don't have to say thank you. But it will be appreciated by your machine friend. And there are people out there that will say that AI may have emotions one day. They may or may not have them now. But anyway, on to the next thing. Just like hello, hola, or bonjour, and how are you, como está, and comen a la voix. These are all the building blocks of data language and how we converse with databases. It may not be in a language that everyone understands, but you, as a human, can serve as the translator from English or even just a question to a database query. Best practices. I'm not going to touch on best practices too much, but these are generally related to typing styles and syntax to follow. Capital and lowercase, it is really up to you. I prefer lowercase just because that's how a lot of programs are written. There is also camel case and snake case where if there's a space in a variable name that you want to give it, generally you either have to remove that or add an undercase to that. I prefer snake case, and a lot of data scientists that I've worked with in the past prefer snake case over camel case. You will probably encounter a lot of developers, though, that enjoy camel case more when they write SQL queries or when they write their code. This is purely a matter of preference or a preference of the shop that you actually work at the time, or even just what you want to analyze. My advice is to make sure that whatever you choose, whether capital or lowercase or camel case or snake case, you stay consistent. So if your databases have snake case or camel case, then I would recommend all of your other tables and all of your columns also follow that same thing. Whether it's camel case or snake case, like I said, doesn't matter. As long as you do it every single time for every entity that you work with, you'll be successful. The last thing is software-specific syntax. And the reason that I put this on here is because I'm not going to be around forever. However, after this class, you can always feel free to message me either on LinkedIn, or I will provide you my email and phone number, and Slack as well. You can always ask me a question, and I will try to get back to you as quickly as I can. But in the event that I'm not available, or maybe I'm on my honeymoon, or maybe I'm on vacation in the middle of the wilderness and you can't get a hold of me, it is important to know that depending on the software that you use to query SQL data or to query data with in SQL, there could be different syntax. And you don't have to memorize every single piece of syntax. But the most important part is knowing what to Google or to hopefully retrieve an answer to your question. So if you're working on MySQL and you forget the statement to return the current date, you can Google MySQL return current date, and it will give you the exact syntax that you use that's specific to the MySQL program. And as an example of how this can vary, if you want to query the current date, Microsoft SQL Server always uses getDate. And in MySQL, we use curDate. And in Oracle, they use current_date. And there is very little overlap in some of this software specific syntax. So that's why I want to point out that when you do have a question and you have to Google it, or maybe who knows, in a couple of years, it could be chat GPTing it. You'll want to make sure you specify what system you're working on so that you can get a result that is specific to your database program. And then the last thing, which is a little bit more of a complexity, but you'll notice how in a lot of these examples, I talk about understanding what each row in a table represents. And it's important because each row could be aggregated upwards, either in the form of a sum or an average or a minimum. And it's important to know if you may have duplicates. So like, let's say we talk about a sales transaction table where each line corresponds to a person buying a specific object. And there could be multiple records or multiple objects sold in a single receipt. If you wanted to take the average of all of the items that are sold at the store, you could simply do an average across that column. But if you wanted an average value of every transaction or every receipt, you then have to also group by the receipt number. And if you wanted to see the average value of a specific product type on a receipt, you would then have to group it further by the product type, in addition to what did we say? Sorry, my memory is getting shot. It's later in the class, but please forgive me. That's a basic example of why you want to declare or understand the granularity of your table before you start to think about how you're going to formulate it, because there's always going to be a difference, or there's always going to be a little catch in how you formulate your query and apply that into your SQL. But that's enough of me talking, at least lecturing. We're going to talk about a little bit about our development environment, and then we're actually going to get into the database and start to write our queries. But first, we're going to talk about the development environment. The way that I structured this is that any of you could potentially do this if you wanted. I've not spent a single dollar on computing, storage, setup, or administration for our environment. And I put together a document that'll actually teach you how to set up a cloud-hosted MySQL server in Amazon Web Services, which is a cloud platform. So you'll have the opportunity to experience what it's like to almost be a database administrator. Learn how to set the platform up. Learn how to create and ingest tables and data into your database. Learn how to manage security credentials for users and make sure that only specific users can access that data. Most importantly, security. But like I said, I prepared a guide for you that'll allow you to step through this if you want on your free time. It's not an assignment. It's not a requirement of the class. But afterwards, once you've completed it, it could be valuable to you if you wanted to start a side project or you wanted to start storing data and then eventually analyzing it. In our database, before we started this class, I asked you all to send me your IP address so that I could add you to the whitelist to access the database server. Everyone should have access now, and you all have your own username and password. Each of you only has read-only access to the Learn database. You probably saw that there are two databases for each of you. There's a Learn database, which has some tables in it, and then there's a learn_your username database. What we're going to do is we're going to copy data from that Learn database or extract data, and then we're going to load the data into your database. This is an example of the ELT process, or the ETL process that we had talked about near the beginning of class. And this is a very good example of how companies commonly take data out of either a software program or their own application and then load it into the source data or the analytical database, or you could call this a data warehouse, and only bring in the tables that are valuable to us. Then, if we wanted to, we can transform the data in our personal database or our data warehouse to our heart's content. And we don't have to worry about the original source becoming corrupted or having another individual wipe data out or manipulate a certain column. what I'm trying to say is there's little fear of failure. You can experiment with the tables with anything we've talked about in the class. You can add additional columns. You can alter columns. You can update them. You can drop an entire table if you want, and you can even rewrite back in there. You have all of these options, and you can do it to your heart's content. That's the best part about this. So now I'm going to teach you how to copy data from database to database. This can be done relatively easily. And the best part about this is you don't have to declare a schema before you import or copy the table from one database to the other. So long as it's on the same database server, you can copy anything you want into your own database, so long as you have permission to write to the database. So the syntax here is that you're going to want to define the database that you work on. And this is going to be the case for every query that you start. You have to declare the database you work on in MySQL because it's not automatically given. In MySQL Server, for James and Ted, MySQL Server, or not MySQL, Microsoft SQL Server will actually allow you to skip this step entirely, because Microsoft SQL Server will ask you what schema you want to query against in a drop-down option bar. We can talk about that outside of this class if you want. The next step is, if the table already exists and you want to rewrite the original copy of this table into your database, you want to drop this table. And I add an if exists clause, because if the table doesn't exist, this command can just be skipped instead of failing outright. When you write automated procedures, or you start to get into things like an ETL job, if you forget to add this if exists and you refresh the data every time to have the most up-to-date current information, if you don't have the if exists, this is the part of the SQL statement that's actually going to fail out, and it's going to prevent your ETL from moving forward. So it's important to include the if exists if you're reloading the table entirely every time. Then the final step is actually creating the table copy from the result of your SQL query. So it's as easy as this: create table, and then learn underscore your database. So if it's mine, we would be doing learn underscore S McQuiston dot table one, whatever that table might be. And then on the next line, we'll write our select statement. We'll select everything star from our source table, which in this case is table one from the learn database. So now we're going to practice. Your objective, your assignment right now, is to copy the US zips and the calendar tables to your own database. This is your syntax reminder. You're going to use your database. You're going to drop the table if it exists, and then you're going to create it. So I'm actually going to take a screenshot of this here quick. I'm going to exit out of this and go into MySQL Server. Does everyone have their connection open to MySQL Server right now?
Yes.
Yes.
Okay. All right. I'm going to assume that everyone's got that all ready to go. And I'm actually going to hide this so you don't have the answers. But the first thing that we're going to do is we want to declare what database we're going to run this against. So I want to use learn underscore my database.
Sam, are you able to make that a complete screen? Because those letters are really small.
I'll zoom in. My apologies. I have a pretty big monitor. It's a really high resolution. Thank you for mentioning that. So the first thing that we do is we're going to use our own database, and then we're going to run this command. We're going to click this lightning bolt with the little keyboard cursor on it. What this does is it only executes the code that you have highlighted. So I'm going to highlight it, and then I'm going to run it. And we should get a success in action. Yep, down here. So we just used learn underscore S McQuiston, And now the next thing that we want to do is drop our table if it exists. So the table that we want to load in first is going to be called calendar. And another note that I totally forgot to mention, this is specific to MySQL Server, and I want to say IBM and Oracle. You have to terminate, which means end your statement that you're asking the computer to run with a semicolon. This is required, so if you try to run the command without the semicolon, it'll actually fail because you have an error in your SQL syntax. But as soon as you add that and rerun it, it'll allow you to successfully execute the command. Next, I'm going to drop the table if it exists. And it's going to give me this little yellow triangle, exclamation point. And it's going to say, well, I can't drop this table because it doesn't exist. This is a temporary warning that is not going to stop any automated processes if you have any. And then the next thing is we're going to actually load the table in to our database. So I am going to create table, and I'm going to call it calendar test, because this is an example of how you can change the name of a table. You don't have to use the same name. You can call it whatever you want. So in this example, I'm going to call it calendar test. And then on the next line, I'm going to ask SQL to give me all the data I want to import into this table. So since I want to import a table that's already called calendar here in our schemas, I'm going to select star, or select everything from, and then I have to define the database that I pulled this from. So if the calendar table lives on the learn database, I have to prefix this with learn dot, then the table name. So the table name is calendar. What this statement is saying is I want to create a table called calendar test on the learn S. McQuiston database. And in this table, I want all of the data from the calendar table on the learn database. And when you run this, it's going to create that table with all of the data that's in the source table. So we have 36,159 rows that were in this learn.calendar table. But what if I want to actually look at this data now? Well, what I'm going to do is I'm going to select all of my data from the table that we just wrote to, or the database and the table we just wrote to, which is learn S. McQuiston dot calendar test. I'll terminate my statement with a semicolon, and I'm going to run this, and it's going to return all of the data in default ordering that's in this table. So what does this table represent? Well, there's a few things that we could add onto this query to really understand what's in the calendar table. Remember how we talked about the min and the max functions? Well, what if I wanted to know what the earliest date is and what the latest date is in this calendar table? I could actually run a statement, a min statement, and return the minimum value of date, which is an actual keyword in the table. And then I can actually alias this as minimum date so that I know exactly what it's querying. Then I'll have a comma. And if I want a maximum date, then all I have to do is write max and then feed it the date argument, because we want to know what the latest date is in the table. And we're going to call this maximum date, so that when this table returns, I should have two columns, one row. The one row is going to return dates, which is what we're querying here. And the first column is going to be called minimum date, and the second column is going to be called maximum date. So if we run this, we get that the minimum date in this table is 2001, January 1st, and the maximum date is year 2099, 12/31, December 31st. Does this make sense so far?
steps I'll have to probably rewatch, but I'm tracking where you're going. It's just being comfortable with when to put what where.
Sure. Let's start out with this. Has everyone been able to add in the new table successfully to their own database? You can type yes in the chat if you want, or no if you haven't been able to get there.
Not sure. Not sure. Well, it says it did, but I would have thought I would have saw it under my learn table.
Okay. So if it's not showing up quite yet, what you might have to do is click this refresh button on the left side in this schemas bar. You'll notice how right now I've created the table on my database, but I don't have any tables showing up here. If you click the refresh, you'll notice that a drop down pulls up right next to tables if you
Yeah.
successfully imported a table, and it'll show it right there. Are you able to see that?
It's there.
Okay. So hopefully everyone has been able to get the calendar loaded into their personal database. We'll go on to the next example. Let's say we want to load in the US zips table now. We're going to use the same database. So I'm just going to run this command again just to make sure that we're on the right database connection. Then, I'm actually never mind. I am going to add this here. So select star from learn. This should be something similar to what you guys will run to connect to a database, drop a table if it exists, then create a table, a copy of a table from another source, and then select it. Return all the data that you just extracted out of the source database. Okay, so Charity, it says you're getting an error when you run the command. Would you be able to tell me what the error is? Or Anna, I think both of you guys are having the same problem.
So when I'm running it, it just says like the action is use learn underscore, and then the response is code 1044. Access denied for user Cmondi.
Okay, let me check credentials here. So go to your user account, schema privileges, learn underscore Cmondi. Looks like you should have access. You said you got an error that said you didn't have access to write to the table. Is that right?
Yes.
Okay. In your query, did you run the first statement that says use learn underscore Cmondi?
I'm gonna run it right now. Access denied.
Access denied? Okay. Is anyone else? Anna, you said you're getting the same error, right?
Yeah.
Okay. Both of you are at home, correct?
No, we're here in the office.
Okay, you guys are at the office. Would you be able to use the whatismyip.com feature again, and then in Slack, send me that IP so that I can make sure that it hasn't changed from what it was before?
Oh, it probably did because I think the IP address I gave you was from my home.
Oh, well, that might be it. Nate and I tested this earlier, and it looked like the IP address for the classroom was the same regardless of the device that you were on. So if it has changed, then I'll have to update that to the IP that you guys are connecting from. But that's most likely the error that you're running into. Oh, looks like it's the same, I think.
I'm gonna pull it up right now.
Okay.
I was gonna say I provided my
Home.
home IP address. I don't know if that makes a difference.
I know, I did too.
Is it the same that I put? Yes, the same one I have.
So everyone other than Cherry and Anna, so Ted, Ryan, Rochelle, James, and Brenda, were you all able to get the queries to run correctly? Brenda, it looks like was a yes.
Yeah, I was.
Okay.
Yes.
It looks like I did, but at the same time, I'm not getting the. Doesn't look like the information is executing. Okay, that looked like yours was. So
Okay.
it may just me just going back through the steps though afterwards.
Okay. Anna and Charity, we may have to debug this later. I'm not entirely sure what the issue is right now. I've made sure that that IP address you both provided is whitelisted. I'm wondering, have you left the program open? I'm guessing you guys are on laptops. Did you open MySQL Server, connect at home, and then close your laptop, go to 75 North, and then open the laptop back up?
Yes,
Okay.
I do.
That might actually be the problem. What I'm going to recommend is you actually quit out of MySQL Server or MySQL Workbench. So close the application out entirely, and then open it back up again and reconnect, and see if that works.
I know I had to put my password again that you provided, and that's how it went through.
Okay. So for the rest of you, James, Rochelle, Brenda, Ryan, and Ted, while we get Charity and Anna up and running, I'll put you guys on the next task. Using this same framework, copy over the US zips table from the Learn database over into your own personal database. Sound good?
Yes, sir.
All right.
You the same one. Yeah.
So I did that, and it's still giving me the same error message.
Still giving you the same error? Okay.
Same. I mean, we can keep going, and I can try at home.
Yeah.
Okay. Thankfully, I think everyone was able to get it to work at home. So I'm sorry that we're not able to get it to work at 75 North. But I'll still be available after class, outside of class hours, to help you guys get through any other technical issues that we encounter. But for the time being, these are going to be our only two class examples tonight. And then we're going to talk about the homework assignment for tonight, and how you might be able to use the resources in the PowerPoint to help you actually formulate a lot of these queries. So apologies that we ran into an error tonight, but hopefully we don't have any going forward.
Sounds good.
All right. James, Ryan, I am not seeing any tables in your guys' databases. Did you have any issues getting the queries copied over, the tables copied over?
That must be what's going on here, because I'm just typing everything you did to see, and I'm not seeing anything action output. So something's not going over.
So when you highlight the use and then your database, are you clicking on this lightning bolt here with the keyboard cursor on it?
Nope, I was hitting the other lightning to the left of that.
Okay.
Yeah, I was having the same thing. I was hitting the wrong button.
Okay. Yeah, there's two lightning bolts. The first lightning bolt is going to execute everything if you don't select. And then the lightning bolt technically you don't have to select anything so long as your cursor is within the start of a command and what we terminate with the semicolon. It's going to automatically only run that. So I prefer using the execute statement under the keyboard cursor each time. So I would recommend doing that. But when you run that and click this keyboard cursor, are you able to get some action outputs showing up below here?
Yeah, that fixed it for me at least.
Okay.
I'm getting action items, but I think I must not have it under the right table then. Maybe I was using it something different here.
Okay.
Okay, I'll figure it out. You have an error in your SQL syntax. Check the manual that, what's that? Correlates maybe, I'm not sure. Oh well.
Hey Sam, so Anna just changed. You know how you have learn and then your last name.
Yep.
She changed it to her name and hers worked. So if I change mine
But
to
it
my
didn't
name,
drop
would
the
it work?
tables. It gave me a green check mark, but it didn't drop the tables.
Oh.
Or maybe because I didn't run the drop tables yet. I'm not
You
sure.
put the one with the white one.
Is it- Maybe I did that.
Did it work?
Maybe. I don't know. It gave me a yellow triangle. No, it didn't drop tables, but it did something. It's not nice. I don't got anything. What should it have been? Did I drop tables on me?
I don't think he switched.
See, yeah, I didn't drop it on me. Oops.
Let me try that again. Here's learn.
just pasted this exact screenshot right here that I took into our Slack channel so that you can use it for your own reference when copying the tables. I'm going to check and see how everyone else is progressing. Brenda, looks like you were able to get both of the tables in. James, Ryan, you must be having a couple of problems. Can I help you?
Honestly, I'm not even where to start because I can see under the schemas, I got learn and tables. Under that, it says calendar and US zips, but then I have a secondary one where it shows, learn underscore my name and then tables underneath there. It's almost like I got it segmented out between the two of them. Am I supposed to have those tables under the learn sub?
No, so you should start with nothing in there for now. Do you have a query window open where you can actually type these commands in?
Yes.
Okay. Were you able to create the first line, which is where we declare the database we want to work with?
Yes.
Okay. And you were able to run this successfully, right?
It's when I do hit that, it says, green check, 0 rows affected though. It just says
Okay.
use underscore and then nothing
Yep.
really exists. Okay.
And so the next command that you want to use is this drop if exists calendar, because we want to make sure that if there is something in the table that we drop it.
Yeah.
But for now, we don't need to use it. When you run it, you'll get one of these exclamation point triangle error messages, which is essentially just a warning.
Yes.
So we don't need to run that right now. If you
Okay.
want, we can skip directly to step 3, which is where we create the table that's going to show up under your database. So you want to run this command. Were you able to get that to work?
I've copied it word for word that you have, and when I do it, it's X that says error code. You have an error in your SQL syntax. Check the manual that.
Okay. Do you have a semicolon at the end?
Oh, maybe that's it. That must be it. Nope, we're good. Thank you.
All right.
Jeez.
And now write a select statement to return all data.
Okay, thank you.
All right. James, were you able to get the tables created?
I thought I was. It was there for a second at the action output, but I think it went away.
Okay.
If I delete the return all data command, I think it works. Yeah, when I'm trying to return all data, it doesn't work.
Are you getting an error on that?
Yeah, it says
Okay.
table.
I wonder if I'm getting an error too.
Underscore jjones.calendar test doesn't exist. I think I see what I did wrong. I think.
Doesn't look like this.
Yeah, I keep getting error code 1146 table quote learn underscore jjones.calendar underscore test quote doesn't exist.
Okay, so in your create table, does it have create table and then the table name that you gave it, and then select star from learn.calendar?
Yeah, I think I see. I added a semicolon to.
The semicolon.
That fixed it.
Awesome. I think everyone's got their tables created. So James, the next thing you'll want to do is actually, now that we have the calendar table created, the next thing that we'll want to add is the US zip code table. So all you'll have to do is update the script that you just created and then copy this table name down here. So since this is the table that we want to create, we're now going to create it here in the third step. And we're going to select it from our source table. So it's titled learn.uszips. And then in the fourth, we can just change this. Since we've already written all this code, all we have to do is copy and paste the exact values that we want. And we could rerun these steps again. So since we're already using the learn database, we technically don't need to run this command. Then we can drop the table on our local database if it exists. Then we can create the new table. And then we can select it. And return all our results.
What did you do? My computer's dying. I don't know what happened. I think it's dead.
And it looks like I still have a little bit of admin work to do. The way that I was actually checking to see your progress was using the admin account for this database. So hopefully you guys are all able to successfully get the US zips and the calendar tables copied over into your own database. But the next thing that we're going to do is I'm actually going to show you some of the exercises and some examples of questions that you might be able to ask. As well as some questions that are on the homework that you guys will have. And we'll hopefully try to get it completed by next class on Monday. So for the time being, I'm going to skip through this. Remember, we have basic queries, which will return a list. And then we have aggregate queries, which will return groups of data. And these are some of the questions that you might be able to answer with like a basic query syntax. You could ask the table, or using SQL, what are all of the zip codes in the state of Iowa? Or you could ask the database engine to return a list of every county in Oregon, ordered by name. You could also ask what time zones Nebraska observes, because those are attributes that we have on this table. And you could also ask how many unique town names are there in Colorado. When we move over to the aggregates, some questions that you might be able to ask are, what's the total population of every state? What's the average population density of every county? What are the most common county names in America? Or how many people observe each time zone? Each of these can be broken apart into individual pieces. If we wanted to ask what all the zip codes are in the state of Iowa, I might ask SQL to return, select all from the US zips code where state equals Iowa. Or I might even filter that down to just say, select the zip code column from the zips table where the state equals Iowa. If I wanted to ask what time zones Nebraska observes, you might have to ask select distinct. Otherwise, you'll select every row in the table, and you may have multiple of the same time zone. So when you select distinct, we return the unique values for that time zone column. We still bring it from the US zips table. And for Nebraska, we'll just ask it where the state equals Nebraska. When we do an aggregate, we have to think about how we might want to mathematically add or group together this data. So if I asked you to return the total population of every state, you might select the sum of the population column from the US zips table where, well, you wouldn't have a where clause, but you would group it by the state. So you would group by state. If you wanted to order it so that it's in alphabetical order, you could order it by the state name in ascending or descending order. And then if you only wanted to return a certain amount of states, you could limit the results to only the top 10 states, or you could limit it to 15 states, or you could limit it to something specific like 32 states. The options are endless, but you as the programmer are the one that gets to tell the machine what to return for you. So a little bit of a surprise. These are actually the questions that are on the homework for tonight's class. I'm going to paste in the SQL file that you guys will be able to open into MySQL, and it will give you the template of all of these questions that I'd like you guys to answer before we come to class next time. This will be due by next class, so Monday at 6 o'clock Central. And there's 10 total questions. One of them is bonus questions. I did actually go through a couple of these examples already, but it's frameworked out so that first you'll initialize your database connection. We want to make sure that we get used to using the database that you're responsible for or that is in your personal zone. And then after that, you'll write a query, a select statement under each of these commented out questions. And then after you write your query, you'll want to select all of it or highlight all of it and then run your query to make sure that the results are accurate. So to get you started, I'm going to help you out with the first example. The first question is, what are all the zip codes in the state of Iowa? Bonus points if you can return the list in alphabetical order. If we want to generate a list of zip codes, maybe I don't know how many zip codes there are in Iowa, but I know what table I'm querying. So I'm going to start out with asking my database engine to just select star or return all records from my database, which I'm actually going to add the line here. I'm going to use learn underscore S. McQuiston since that's my database. I'll run that command. And then under question 1, I'm going to select all or return all records from the US zips table. And I'm just going to run that to see what kind of results I get back. And now that I have my results down here, I know what all the column names are. So if I want to return zip codes in the state of Iowa, I know that zip codes are a column. So under select, I'm going to return zip. If I only want to return zips in Iowa, I'm going to filter my results using a where clause, where the state ID, or you could do the state name, equals, using an operator, and then type in Iowa. When I run this, I now get a list of all of the zip codes that are in Iowa. And right now it's currently ordered in not technically alphabetical order, but it's ordered in ascending order because that's the default that the data was stored. If it wasn't, you might see some of these numbers out of order or not in an order that you would expect. So to add that or to fix that, you'd want to add an order by statement where you order by the column that you're returning, zip, and then you can declare either in ascending or descending order. Since this data set's already showing in ascending order, I'm going to show you the example of what it looks like if we sort it in descending order. I'll run it, and you can see that our top zip code value is 52807, and it goes all the way down until we get to 50001. So that's an example of how you'll be able to answer these kinds of questions using SQL. I will send out the PowerPoint, the template for the homework questions, as well as a few additional resources to help you guys get started. And if you have any questions over the next week or even over the weekend, feel free to shoot me a message or an email, and I will do my best to help you and guide you in the way that I wish I would have been guided when I was in your shoes. But other than that, class is over for tonight. Next class, we'll have a really short quiz that covers some of the material from tonight, and nothing on the quiz is a surprise. I'm a pretty open book professor, so you will have your materials available to take the quiz, because the most important part about being a developer is being able to be strategic with your resources. It's not cheating if you're given some of the materials to learn from. Like I said earlier, the most important part about being able to solve a data-related question is knowing how to phrase some of your questions for like a search engine. If you have trouble getting data returned or you're encountering an error, it might be useful to try and search for the error and maybe understand what it means. But otherwise, some helpful resources are going to be the MySQL tutorial website that I had mentioned earlier. You can also use the developer resources on mysql.com. You can also reach out to me or Nate. Your instructors definitely want to help you succeed. And more than anything, that's what I'm here for. Lastly, there is a book that I had talked about earlier in this lecture, which is called How to Measure Anything. I actually have it right here. This book was something that I picked up in college that a professor recommended to me, and it kind of opened my mind on how data behaves and how we can measure things that maybe aren't stored for us in the most friendly way. It's a good resource. It costs about $30 if you're interested. But otherwise, that's it. That is our class for tonight. And I don't have anything else for you guys. But if you do have questions on the homework, like I said, please reach out and I'll do my best to help you out. Are there any other questions before we sign off?
Did you say homework was due the day before class or the day of class?
The day of class. It can be due all the way up to when we start class at 6 o'clock next week.
Thanks.
Yep.
And you're just looking for us to post the queries that we've written directly to you?
Yep. So in the SQL file, I'm sorry, I wasn't a little bit more direct with this. I will send you a SQL file that has all the questions for the homework. You should be able to just double click on that file and it'll open up in MySQL Server or MySQL Workbench by default. And you'll see all of the questions for the homework commented out. If you do have issues with it, I'm actually going to paste a screenshot of all the questions into our Slack channel, and then you can just write the queries out. Once you're done, you'll want to go into MySQL Workbench, click on File in the top left, and then you'll want to save the SQL script as your class 1 homework answers with your name so that I'm able to differentiate that when I grade you guys. If there are no other questions, I am going to go ahead and end the stream for tonight. Once again, thank you all for being here and working through some of the technical issues with me. Hopefully we don't run into any in the future, but if we do, please let me know. Do not keep it a secret.
Thank you, Sam. Good night.
All right.
Thank
Bye,
you.
everyone.